Hello LHS, Miss Barber here with lesson 9.3 in geometry. Adding on to what we know about our area formulas, we're going to find the area of composite figures. So the figure to the right here is called a composite figure. It's called that because it's made up of simple shapes we know. So think about area formulas we know. We know squares, rectangles, triangles, circles. So technically we know the area formula for a semicircle, half of a circle, and regular polygons. So in order to find the area of a composite figure, you have to break it up into shapes that you know. So in this case, there's a few different ways you can always break it up, but in this case, the easiest thing is if I draw a line and I can break it up into a rectangle and a triangle. By doing that, then you have to find the individual parts. To find the area of the rectangle, it's quite easy because it's just going to be 18 times 7, base times height. What's a little more challenging is for the triangle, because they did not specifically tell you either the base here nor the height, or whichever one you want to call it. But we can use subtraction and do 11 minus 7 to find the height, because the whole thing on the left here was 11, and then this part was 7, so that has to be 4, which is left over. And then horizontally, the whole thing is 18, and the top here was 13, so what's left over has to be 5. Then we can find the area of the triangle and the area of the rectangle individually. So here's the area of a triangle formula, and then here's the area of a rectangle formula. Substituting the numbers in, we get 10 and 126, and then we can add them together. So that's how you find the area of composite figures. You might break up the figure differently than the friend sitting next to you, and that's perfectly fine. As long as you're coming up with the same answers in the end, there's a few different ways you could break it up. So number one, I have this composite figure, and I see it as two separate rectangles. Again, you might break up the rectangles a little bit differently than I am, but I'm breaking it up with this top little part up here. I'm going to call this little figure up here figure 1, and this figure here, the bigger one, 2. Well, figure 2, it's pretty easy to find its area. You just do base, which is 28, times height. So figure 2, it's quite easy. It's just going to be base times height, which is 28 times 15. And 28 times 15 is 420. So that's figure 2. Let's look at figure 1. For figure 1, they told me the whole thing was 28, and the part parallel to it horizontally was 22. So the part I just highlighted in green there would have to be 28 minus 22. And 28 minus 22 would be 6. So that's the base. To find the height, the whole height on the left here is 20, and 15 is part, so it would be 20 minus 15, which is 5. So for figure 1, my area would be base, which is 6, times height, which is 5, and 6 times 5 is 30. So adding 30 and 420 together, total, my area is 450 yards squared. So number 2, there's a few ways you can break it off. In my mind, I immediately see a triangle and a rectangle. I'll call figure 1 a rectangle and figure 2 the triangle. So figure 1 will be easy to find the area. It's just base times height, 10 times 9. Which is 90 millimeters squared. Now, to find the base and the height of the triangle, let's find the height first. They told me the whole thing was 9, and the part that I'm not using is 3. So I can say 9 minus 3 will give me the height, which is 6. To find the base, the whole thing was 14, and the part I'm not using is 10. So 14 minus 10 would be 4. So for figure 2, it's a triangle, so it's going to be base times height. So 4 times height divided by 2. People tend to forget dividing by 2 for triangles. Don't be that person. And you get 12 millimeters squared. So now I can add up to my two answers, 90 and 12, and I'm going to get an area total of 102 millimeters squared. Oops. For number 3, I have two figures. I have a semicircle on the left. I'll label that 1, if I ever can label it 1. And I'll label this on the right a square, 2. To find the area for the semicircle, the area of a circle is pi r squared, but I'm only finding half the circle, so I'll divide that by 2. They told me the diameter here would be 16, but remember, I need to know the radius. Well, the radius will be half the diameter, so in this case, the radius should be 8. So the area is going to be pi times 8 squared divided by 2. For right now, let's just keep this in decimal answer. Makes it easier. So 8 times 8 is 64 divided by 2. You're going to get 32 pi. We'll find out what the decimal is of that once I add these together. So number 2, this is a square. The base and height are both 16. So you can either do 16 times 16 or 16 squared, which is 256. Adding 256 with 32 pi together, you can use your calculator, adding these two together, and you're going to get 356.53 feet squared. Then lastly, number 4, you can break it up. This is the easiest in my mind because you break it up into only 2 things, and it's 2 rectangles. The rectangle on the left, number 1, base times height would be 3 times 8. 3 times 8 is 24. On the right, it would be just 6 and 2, so this one's quite simple, which is 12. And then I just add 24 and 12 together. And 24 plus 12, you're going to get 36 meters squared. I'm comparing this to my answer key, and I can tell you my answer key has a few wrong, so hopefully people are watching the video and not just relying on that key. Whoops. All right, let me figure out how to scroll. Technical difficulties today. All right, we're back on track. All right, you can also find the area of a composite figure by using subtraction. Sometimes that's easier instead because you'll have to break up the figure into too many separate shapes. So to do that, you subtract the area of the square from the area of a rectangle. So here in this figure, if I find out what the area of the rectangle is, and I can subtract off the area of the square here, that's going to be a lot easier than dividing this up into 3 separate rectangles. So the big green would be 12 times 9, which is 108. The square would just be 4 times 4, which is 16, so I can subtract and get 192. So all that math is shown there on the left. If you have irregular shapes that are on a coordinate grid, you can also break it up and make it look like shapes that you do know. So roughly A looks like a square here, and B looks like a triangle. And we can find the area of both of those because the square is 2 by 2, so 2 times 2 is 4. The base of the triangle is 2 as well as the height. 2 times 2 divided by 2 would be 2. So even though it's irregular, hopefully you can break it up and see some shapes that you know. So number 5, using subtraction, I have a big rectangle here. So my big rectangle I'm going to find is going to be 22 times 18. So 22 times 18, you get 396. Now I have to find the area of my triangle. Well, the area of the triangle, the base is 22. So base is 22. My height is 9. And then remember to divide by 2. 22 times 9 divided by 2 is 99. So I can do rectangle minus the area of the triangle, and I'm going to get 297 millimeters squared. Letter 6, number 6, you have to use subtraction because I can't break this up, the shaded area, into shapes I know because of that semicircle that's being cut out. So first, let's find the area of the big rectangle. Should be pretty easy. It's just going to be 9 times 5, which is 45. Now let's find the area of the semicircle to subtract off. Well, I need to know what the radius is because remember, for a semicircle, it's going to be pi r squared divided by 2. Well, my diameter is 5, so my radius should be 2.5, half the diameter. So it's going to be 5 times 2.5 squared divided by 2 because, again, this is only half of a circle. And that's roughly rounding 9.8. And now I subtract 45 minus 9.8. You get 35.2 centimeters squared. Number 7 and 8, estimating area. So again, break it up into shapes that you know. I'm going to break it up like this. This roughly is a rectangle. That's 2 by 1. And so base is 1, height is 2. 2 times 1 is 2. This shape on the bottom is also roughly a rectangle where the base is 3 and the height is 2. 3 times 2 is 6. Then adding 2 and 6 together, 2 plus 6, I'm going to get 8 centimeters squared. You could also just try to individually count up the squares if that's also what your heart desires. It is harder though when they're kind of half squares. As in number 8, so because this is half squares, I'm going to break it up into 2 parts. The top part's going to be a triangle, the bottom part's going to be a rectangle. So for this triangle, the base is 3, the height is 2, and remember you have to divide by 2. 3 times 2 divided by 2 is 3. So that's the area of the triangle. The area of the rectangle will be just 3 times 2, which is 6. So add 3 and 6 together, and you're going to get 9 centimeters squared. That's it for finding area of composite. Stay tuned for lesson 9.4, which is the area of irregular shapes, and find